When you have exponential equations and you're being asked to solve them, the first thing you want to look at is whether or not you can rewrite the bases in terms of a similar base. So let's look at example A, and since this is 2 raised to a power, is there a way to express 16 as a power of 2? So if we think about 2 times 2 is 4, times 2 is 8, 2 times 8 is 16, we can write this as now, since we're looking at two expressions that are equal to each other, the bases are the same, then we can set our exponents equal to each other. So then we can say that 3 minus 8 is equal to 4. So 3x is equal to 12, and x is equal to 4. We can check our solution by substituting it back into the original exponential equation. And is it true that 2 raised to the 3 times 4 minus 8 power is equal to 16? Well, that is 2 raised to the 12 minus 8, which is 4. That is 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16. So this is true. We know that our solution, x equals 4, is correct. The second example, when we look at the bases, we have a 5 and 137, and there is no way to express 137 as a base of 5. So we can't say 5 to some power will equal 137. So the strategy for solving an equation that's an exponential that we cannot express with like bases is to use logarithms. And we can use log of both sides, or we can take the natural log of both sides. In this example, I'm going to take the natural log of both sides. And then I want to use the properties of exponents to rewrite the left side of this equation so I don't have an exponent. So that becomes x minus 3 times the natural log of 5 equals the natural log of 137. Now remember, my goal here is to solve this equation, so I'm looking for x equals. So now I have x minus 3 times the natural log of 5. Well, let's divide everything by the natural log of 5. So now we have x minus 3 equals, and we keep everything in exact answer form. And the final thing we need to do to solve for x is add 3 to both sides. So x equals the natural log of 137 divided by the natural log of 5 with 3 added to that ratio. Now, another thing that you might be asked to do on this is to give an approximation. And I want to grab the graphing calculator and let you see what that's going to look like. One thing you need to be very careful with when you're using a graphing calculator or any scientific calculator is the parentheses around the arguments of the logs. So I'm going to do natural log, and it opens parentheses for me, 137, and this is the critical point. You must remember to close the parentheses on that argument. Then divide that by the natural log, it opens parentheses again, put 5 and close the parentheses, and then add 3 to that. That gives us 6.056956027. We're going to express the answer in the terms that are stipulated in the problem itself. And let's say that we need to express this answer in 2 places. So that means x is going to be approximately, and when we look at our answer here, we see that next to the 5, so I want to round at the point of the 5. To the right of that is a 6. That means I'm going to increase the 5. And this becomes approximately 6.056. 0.06. So this is my exact answer, and this is my approximation.